Welcome to another key session on large language models, LLMs, and related technologies. These videos are designed to sharpen your knowledge and prepare you for interviews in today's competitive job market. Each video includes a free self-evaluation quiz, and for our interns, we provide exclusive Anki flashcards to help you master and retain these concepts effectively. Let's get started. Wishing you the very best in your learning journey.
All right, let's get right into it. We hear the term deep learning thrown around all the time, but what does deep actually mean? Today, we're going to break down the real difference between a deep neural network and a so-called shallow one. So you've heard all the buzzwords, right? AI, deep learning. But what actually separates a deep network from a shallow one? Is it just hype? Well, that's the big question we're going to get to the bottom of right now. Okay, but first things first. Before we can talk about the difference, we've got to make sure we're on the same page about what a neural network even is. At its core, a neural network is really just a type of machine learning model that's, well, inspired by our own brains. You can think of it as a computer system that's designed to learn and spot patterns in data, kind of like a simplified digital version of how we think. So if both deep and shallow networks are inspired by the brain, what's the big deal? What's the actual difference? Well, it all boils down to one single but super important feature: layers. Yep, that's it. The whole game-changing difference is just the number of hidden layers that are sandwiched between where the data goes in and where the answer comes out. It sounds almost too simple, but trust me, this one little architectural detail changes everything. Every neural network has this basic setup. You've got the input layer, where the data comes in. Think of it like the pixels from an image. And you've got the output layer, where the result comes out, for instance, a label that says cat. But all the magic, all the real thinking, that happens in the middle, inside those hidden layers. So here's the rule of thumb people in the field generally use. We call a network deep once it has 3 or more of those hidden layers. If it only has 1 or 2, we call it shallow. It might seem like a random number, but hitting that 3-layer mark is what unlocks a whole new level of complexity in how these things can learn. But why? Why do more layers matter so much? This is where we get to the really cool part, the core idea of how deep learning actually works. It's all about learning in stages. Just imagine we're showing a deep network a picture of a face. The very first hidden layers, they don't see a face. They don't even see an eye. They see the most basic things possible. Simple straight lines, little curves, maybe some bright spots and dark spots. That's it. Okay, now the next layers in the stack. Take those basic building blocks and start putting them together. They're combining those simple edges and curves into more complex shapes. So now the network isn't just seeing lines. It's starting to recognize the pattern of an eye, the shape of a nose, or the curve of a mouth. And then the final layers do the most incredible thing. They take those pieces, the eye, the nose, the mouth, and they learn to assemble the whole concept. They figure out that this specific combination of features is what we humans call a face. This process of learning from simple to complex, layer by layer, is called hierarchical learning, and it's the secret sauce that only deep networks can pull off. All right, now that we get the whole learning in stages idea, let's put these two network types right next to each other and do a direct comparison. So at the highest level, here's the takeaway. A shallow network is your go-to for simple, pretty straightforward patterns. But a deep network, because of that multi-stage learning we just talked about, it's built to tackle complex hierarchical patterns where the features themselves are built out of other features. And you can see the split pretty clearly here. Shallow networks have just 1 or 2 hidden layers, and they handle simple patterns. Deep networks have 3 or more, and they crush complex hierarchical problems. But, and this is a big but, look at those last 2 rows. That power comes with a serious price tag. Deep networks need way more training data and a lot more computational muscle. It's that classic trade-off, power versus cost. So this trade-off brings us to a really practical question. Which one should you actually use? Well, it's all about choosing the right tool for the job. You wouldn't use a giant sledgehammer to hang a small picture frame, right? It's the exact same idea here. Shallow networks are perfect when you have a simpler task, a smaller set of data, or you just need to build a quick prototype. But deep networks, they're the heavy-duty machinery you bring out for the really tough stuff, like recognizing what's in an image, processing speech, or truly understanding human language. So after all that, what is the one big idea you should really walk away with? I think this quote from our research really just says it all. A DNN is deeper because it has more layers, allowing it to learn richer, more abstract features, which makes it better at solving hard problems. That's it, right there. Depth creates abstraction, and abstraction is what lets us solve the really hard problems. And that leaves us with one last, pretty mind-blowing thought. We know what deep means now. But as these models keep getting even deeper, we're talking hundreds, even thousands of layers. What new, incredibly complex problems are they going to be able to solve for us next? What's just around the corner?
Thank you for watching till the end. Don't forget to test your knowledge with the quick self-evaluation quiz. The link is right in the description. If you found this video helpful, please like, share, and subscribe to support the channel. And if you haven't yet explored our self-paced AI internship program, visit shogini.com for full details. Wishing you all the best in your AI journey.